Can I see conduction, convection, and radiation move heat in different ways? This is the Trust Repair Shop, a project about understanding the world firsthand. I'm not an expert, I'm just a curious person starting a 30-week speed run to recreate important technologies and discoveries for myself so I don't have to take anybody's word for it. So far in this project, heat's mostly been a tool. I used fire to create charcoal, to fire clay. This time, heat is the thing itself that I'm testing. The basic idea is that heat can move by conduction through direct contact, convection through moving air or liquid, and radiation through electromagnetic energy like sunlight. According to the textbook, there's clear differences between these categories, but the real world's a little bit messier, and my first attempts make that pretty obvious. I started with 3 simple comparisons using temperature over time. For conduction, my first setup used hot water in thick glass dishes, one on steel and one on a towel, and that didn't produce a meaningful difference. For convection, I compared 2 hot water containers, one covered and one uncovered, and that worked pretty cleanly. And then for radiation, my first setup used hot water containers in sunlight, one on a black shirt and the other on a white shirt, and that showed only a tiny difference. And the thermometers also misbehaved in direct sunlight. So I took the 2 weak ones and I tweaked the process and tried it again. For a cleaner conduction test, I used smaller plastic containers about equal size. I put one in a large bowl of room temperature water and the other sat on a towel. Both had lids to slow convection. And for the cleaner radiation test, I used mostly sealed air-filled containers. Container A was wrapped in a black t-shirt and B was in a white t-shirt, and both sat next to each other in direct sunlight. The second time through, the test finally showed the effects pretty cleanly. So a container sitting in room temperature water cooled by about 19.5 degrees Fahrenheit. The towel insulated only cooled by 8.6 degrees. For the convection test, the covered sample cooled by 45 degrees over 10 minutes, and the uncovered cooled by 57. Leaving it uncovered let more air, steam, and evaporation carry away heat faster. The repeated radiation test was much cleaner too. The black wrapped container warmed by 41.9 degrees in sunlight, and the white wrapped container warmed by 28.2 degrees. Same sun, same time, different surface color, so very different final temperature. The first version of the experiment, it was frustrating, but it was useful. It showed me that a bad setup can hide a real effect. The second version was much better because the test was designed around specific heat transfer mode I wanted to see. So yes, I could observe conduction, convection, and radiation with household materials, but the deeper lesson is the setup really matters.